Okay, so classification. Classification. So, like I said before, there are three groups. Three groups. Three groups. Specifically three influenza groups. So there's A, B, C. Now, the small details about those groups is that group A infects A, A infects humans and animals, or man beast. B only infects humans, and group C is rare. Dr. Sand did not elaborate on the rare part, just that's not very common. But yeah, A is man and beast, B is man, but this one's rare. So you'll see that influenza A is often the one that causes the most problems because it's able to infect and grow within both humans and animals as 8 genome segments. So what it can do is it can rearrange a bunch of different I guess like alleles of the genes that you have, and you get many novel viruses. You can get even like hybrid influenza, where it might have something that, you might have like a chicken flu that, can raise your fever to above, I don't know, let's just throw a random number out, 105 degrees. And usually that chicken flu only stays with a chicken. But because it's influenza A and it has 8 genome segments and it can recombine all its genome segments, it can now cross the species barrier and infect humans. So now you have a virus that can infect humans and chickens and raise your, when you get sick from it, your fever is now above 105 degrees, and you die. So nothing funny about the death, but it's crazy what food can do. So now, group A is classified by antigens. So group A is classified by surface antigens. B is classified by nucleocapsids. C is classified by matrix. What that means is, if you were working at CDC, which I hope I will be one day, you will look. They might give you like a sheet of paper and say, oh, this is flu influenza A, H1 and 3, and what it's trying to say is you classify influenza A by the by the surface proteins that are on it. In this case, hemagglutinin and ramanidase. You would never classify A by its nucleocapsid, whereas B, you would, if you were to talk about influenza B or something else, you wouldn't refer to its group type by saying, oh, influenza B H2 and 2, right? You wouldn't do that. You would classify it by its nucleocapsid, influenza B and P. So I don't know. So, but that's, I don't know. As in, I don't know off the top of my head of an example of influenza B, but again, it's classified by nucleic acid. This one's classified by the matrix protein. So Dr. Samuels gave us an example classification. Okay, so example of that is influenza A, Hong Kong, 68, H3N2. Okay, so influenza A, that came from Hong Kong in the year 1968, and it has hemagglutinin type, or like serotype 3, and the rhamnitis serotype 2. So H3N2. There are different hemagglutinins and rhamnitises. They do the same thing, but it's just they might differ from each other by a few amino acids, and that makes it a new serotype. That makes it a new surface protein. So it's very intuitive right there. But, that's the kind of classification you see. For B, you'd see something similar, and then maybe right here you'd see NP1 or something. Okay, so this done classification. Pause if you need to. I'm going to split the videos up. I'm going to go, before we go into multiplication, we're actually going to go into important flu proteins.